Now, before we end today's lecture, let's briefly overview the method of assumed state. We will learn about this topic in details when we are studying diodes and MOSFETs and BJT. Uh, let's just see a simple example of how this method works and why this is a powerful method. So the method of assumed state is used for solving piecewise linear equations, or in our case, solving circuits with piecewise linear devices. So there are mainly four steps in this method. First, we have to assume, say this is the IV of our device, right? This is a piecewise linear IV. So the first step would be to assume a state. A state means a line segment. So since we do not know which state the device would operate, what we would do is first assume any of the states. Say let's assume that the device would be operating in the region C, or let's assume that the device would be operating in region A. The next step would be to replace that device with the equivalent circuit of that segment. For example, in this case, we would replace, if we assume that our device is working as a in segment A, we would replace it with an open circuit. If we assume that our device is working in the B region, we would replace it using a resistance and so on. And after we replace it with the equivalent circuit, we would then solve the circuit. Solving means finding all the currents and the voltages. The third step is to check our solution, and this is the important part. Checking means to check if our voltage and if the voltage and current that we have found in step 2 matches with the condition of that state, right? We will see an example what we mean by that, and if it does not match, we have to reduce step 1, 2, 3. That means, say for example, if we have assumed that our device is operating in A region, but the solution does not check with region A. So next we can assume that, okay, the device might be working in B region, and so on. So these are the four steps in the method of assumed state. Assume a state, solve the circuit assuming that state, check if the solution is correct, and if it is not correct, repeat. If it is correct, then stop at solution 3, at step 3. So let's see an example like this. We are given a circuit where a voltage source of 6 volt is connected with a 0.3 kilo ohm resistance, and it is connected in series with a non-linear device, with the anode connected to this point and cathode connected to this point. So it is given that the IV curve of this non-linear device is the same example that we have seen in the previous video. So as we have seen in the previous video, if the for this device, if the voltage is less than or equals to 3 volt, we can replace it using an open circuit. If the current is between 0 and 3 milliampere, we can replace it using a 3 volt voltage source. And if the voltage is greater than 3 volt, we can replace it using this circuit. However, since we have not solved the circuit yet, right, we do not know what the value of the voltage or the current is. That's what we have to find. So we do not know which state the device would work, right? So what we do is we assume any of these state, A, B, C. Let's say, for example, I think the device might be working in B region. So what I do is I replace this non-linear device with this equivalent linear device. It's a 3 volt voltage source. And this is 0.3 kilo ohm. And this is 6 volt. So now that we have replaced the circuit, so we have assumed a state. So the next step would be to find the voltage and the current. So since the circuit is a series circuit, the current would be simply 6 minus 6 volt minus 3 volt. And since there is only one resistance, it would be 0.3. So if we calculate, it would be 6 minus 3 is 3. 3 divided by 0.3 is 10 milliampere. So the current is 10 milliampere, and the voltage, since it's a voltage source, it would be simply 3 volt. Right? So this is our solution, assuming that the device is working in the B region. Now the third step is we have to check if our solution is correct. So is it correct? No. Why? Because notice that the condition for the device operating in B region was that the current should be between 0 and 3 milliampere. However, our current turned out to be 10 milliampere. So it is not possible for the device to operate in the B region. So we have to go to step 4 and we have to assume a new state. Now, since the current is greater than 3 milliampere, let's assume that the device will work in the C region. Um, so our new so assumption, so we would write the assumption wrong. So in this case, the device would not work in the B region. Let's go move on to the new assumption. This is 0.5 kilo ohm. This is 6 volt, and this would be the replacement of this device of this nonlinear device. So since we are assuming it's working in the C region, it would be a resistance in series with a voltage source. And notice the polarity. The negative side would go towards the right. The negative side terminal would go towards the anode, and the positive side would go to the cathode. So this side would be negative, this side would be positive. And the value is 3 volt, and the value of the resistance is 2 kilo ohm. Right? So again, we have to find the current and the voltage. This is the current I, and this is the voltage. Notice one thing to notice here is that the voltage here is the voltage across the device, not the voltage. That means that when we're defining V, the V is actually the voltage across the whole series connection. So in our case, the voltage would be this voltage, not the voltage of the voltage source. So what would be the current? Now, since again this is a series circuit, so the two voltage source, the positive is connected to the negative side, so additive. So the I would be 6 plus 3 divided by, since the two resistors are in series, it would be 0.5 plus 2. So the answer would be 9 divided by 2.5, which is 3.6. So the current would be 3.6 milliamps. What about the voltage? Well, we can find it using Kirchhoff's voltage law, KVL. From KVL, we can see that the voltage would be 2 into I minus 3. So that is 2 into 3.6 minus 3. So 2 into 3.6 is 2 times 3.6 minus 3. That would be 4.2 volt. So the voltage would be 4.2 volt. So the current is 3.6 milliampere and the voltage is 4.2 volt. So we assumed state 3. We have solved for the state 3. Now we have to check if our solution is correct. So as we can see that the condition for segment C was the voltage is greater than 3 volt, right? And our voltage turned out to be 4.2 volt, which is of course greater than 3 volt. So this assumption is correct, and this is the current and voltage for this condition. So this is the correct assumption.